Forget icy moons orbiting gas giants. What if one was so badass it spit volcanic plumes across its surface and defied its own planet by spinning the wrong way? This is Triton, Neptune's biggest moon, and it's about to wreck your mind with its secrets. Get ready for a journey to the darkest, coldest, and most outrageously weird corner of our solar system. It's cold and dim in the solar system's suburbs. Triton, the largest of Neptune's 14 known moons, gets 900 times less sunlight than Earth. Much of that light reflects off the icy world's surface. This makes Triton one of the chilliest places in the solar system, with temperatures that plunge to minus 240 degrees Celsius. In spite of the cold, Triton is an active world. It has very few craters, pointing to a young surface that is being constantly reshaped. Dark volcanic plumes erupt throughout Triton's southern hemisphere and could be linked to an underground liquid water ocean. Scientists says that Triton probably came from the Kuiper Belt, a band of icy objects beyond Neptune that includes Pluto. Neptune's gravity may have pulled Triton into its orbit long ago. Triton is sometimes compared with Pluto. The two worlds have similar masses, diameters, and surface materials, although their topographies differ. Like many other worlds in our solar system, Triton has an interesting origin story. The moon was discovered in 1846 by William Lassell, an amateur astronomer who financed his hobby with money made in the brewery business. Laswell found Triton just 17 days after Neptune itself was discovered. The moon was named after a mythological merman who had the upper body of a human and the lower body of a fish. Triton's father was Poseidon, also known as Neptune in Roman mythology. It's very likely. The first piece of evidence is that Triton orbits Neptune the wrong way in what's known as a retrograde orbit. Like Earth, Neptune spins counterclockwise on its axis. Any moons that formed alongside Neptune should orbit the planet in the same direction. Triton may have melted down when it arrived at Neptune, but it is still facing a grim future. Its reverse orbit means Neptune's gravity is slowly pulling it towards the planet. Millions of years from now, gravitational forces will break Triton apart, possibly forming a new Neptunian ring. The origin caused by Triton's entrance may have flung the moon Nereid, which may also be a captured Kuiper Belt object, into a highly eccentric orbit. Whereas most moons have roughly circular orbits, Nereid travels nearly 7 times as far from Neptune at the long end of its orbit as it does at the short end. Now there is question arises that is Triton an ocean world? We're not sure. Triton's surface is young, less than 100 million years old and possibly less than just 10 million years old. It has very few craters, suggesting that something is constantly reshaping its surface. The reshaping could be caused by volcanic plumes. NASA's Voyager 2 spacecraft saw more than 120 dark streaks on Triton when it flew past the moon in 1989. These streaks, which are probably a mix of nitrogen, methane, and dust, likely came from past subsurface eruptions. Voyager 2 also spotted at least 2 plumes that were actively erupting. One plume was 8 kilometers tall. Now, what causes Triton's plumes? There are 3 main reasons. Sunlight heats and pressurizes dark patches of nitrogen beneath Triton's translucent surface ice until the nitrogen bursts free. Heat from within Triton melts pockets of nitrogen ice, which finds its way to the surface and erupts. The plumes are cryovolcanoes fed from a subsurface liquid water ocean, or from pockets of liquid water locked within Triton's icy crust. The last possibility is the most intriguing and would make Triton an ocean world. If an ocean exists, it may have been created during the intense gravitational stresses and heating Triton experienced when it was captured by Neptune. The only way to know for sure is a new mission to Triton. Only one spacecraft has ever visited Triton. Voyager 2 flew through the Neptune system on August 25, 1989. Voyager 2 skimmed over Neptune's north pole, using the planet's gravity to bend its trajectory towards Triton. It flew by Triton about 5 hours later, imaging the surface from a distance of 40,000 kilometers, barely higher than the altitude of Earth's geostationary communication satellites. Because of Triton's high-inclination orbit around Neptune, its poles swap time in the sun, causing dramatic seasonal changes. Voyager 2 only saw the moon's southern hemisphere, which was flecked with dark streaks. The plumes the spacecraft saw were the first ever detected on an icy world. Closer to the equator, Triton's ice shell gives way to wrinkled terrain resembling a cantaloupe. Triton was the final world explored by the Voyager program. After the encounter, Voyager 2 joined Voyager 1 in sailing onward towards interstellar space. The best near-term hope for a NASA mission to Triton comes from the agency's low-cost, competitively selected Discovery program. A mission called Triton was one of 4 finalists during the last Discovery selection round. Triton was ultimately passed over in favor of 2 Venus missions. NASA accepts Discovery proposals roughly every 4 years, meaning a new call could come as early as 2022. There is less hope for Triton through NASA's higher-cost mission programs. Unlike Discovery missions, the agency's flagship, it may seem like the odds of exploring Triton's mysterious dark plumes are slim, but don't despair. China is considering a Neptune mission that would launch in 2030 and arrive by 2040. The spacecraft would enter a polar orbit around Neptune and deploy 2 small satellites. One satellite is classified as a penetrator, meaning it could slam into Triton's crust like a dart, giving us our first up-close readings of the icy world's surface. Thanks for watching the video. Please also support channel by subscribing it.